Right, on this one, x-intercept of 12, y-intercept of -5. I'm going to go y equals mx plus b. Okay, you have an alternative option. This thing might be useful on the test as well. Okay, know how to use that. And if I use y equals mx plus b, this here is x-intercept 12, so it's 12, 0, and this is 0, -5. We know y-intercept is the b value, so that's -5 there. Now I need m to go with my slope here. So I'm just going to go 12, 0, and 0, -5, and deal with y2 minus y1 over x2 minus x1. So 0 minus -5, and 12 minus 0 gives me 5/12. So the slope here is 5/12, and there's my equation. Number 2, they want to find a line that is parallel to the x-axis but goes through the point -8, 6. So -8, 6 might be that point there. And we want to be parallel to the x-axis, so it's going to be a horizontal line. And when we've talked about horizontal lines, they're always the equation y equals, and then the y value that you know that line's going to have, and it has to go through 6, so it's got to be y equals 6. If I wanted the horizontal line, it's y equals 6. If I wanted a vertical line, so maybe I wanted that line, so the phrasing would be parallel to the y-axis. That line would be x equals -8. When I'm answering part B here, it says the slope of the found in part A. Well, if this is the line they wanted, slope here is 0 for the line y equals 6, but if they did it over in this form, the slope here would be undefined. Okay, vertical slopes are undefined. Okay, this question here, they want you to go ahead and start factoring. So 7x squared minus 7x minus 6 is equal to 0. I could try factor by grouping, but I don't think that's going to work. So I'm just going to revert straight to when these numbers are really ugly. I'm going to go straight to the quadratic formula. So I'm going to go opposite of b, 7 plus or minus 49 minus 4ac all over 2a, which ends up being 14. I believe that gives you 7 plus or minus root 217 all over 14. Just leave it that way. That's fine. That's simplified. Go to the next one. They're asking you here to solve this equation. So when we have an equation like that, we need to multiply by a common denominator. So I'm going to go x plus 4, x minus 4, x plus 4, x minus 4, x plus 4, x minus 4. Or cancel the x plus 4's there. It's going to give me 3 times x minus 4. Cancel the x minus 4's here. It's going to give me plus x times x plus 4. And then those are going to cancel completely and leaves me 6. So the reason they asked this question is because it's going to quickly develop into, right here, you see that x squared, you get a quadratic equation. I'm going to combine my like terms, so I get x squared, 4x and 3x is 7x, -12, move my 6 over, gives me -18. Right away, I think of two numbers that do this. It would give me x plus 9, x minus 2, so x is equal to -9, and x is equal to 2. Once we have those solutions, we just want to make sure that neither of them provide us any domain issues down here. Okay, and basically, you know, x, you guys know now at this stage, x could not have been -4 there. X could not have been +4 there, so those would have been domain issues. And then for the same reason, x cannot be positive or -4 there. So because none of these answers mesh with those domain restrictions, both those, -9 and 2, are answers that would validate this equation. Kind of do the same thing here on this one, but this is a root equation. So in order to do that, we need to isolate the radical. Should be something like that. Now we're going to square both sides. Should be something like that. So now the only thing that we got to pay attention to is that when I square this, it's actually 2x minus 2 times 2x minus 2. So I should get 4x squared, and then it's going to be minus 8x. Okay. Multiply those two things together and double them, and then square the last part would be plus 4, and then is equal to 3x minus 1 on the right hand side. Start combining like terms. I get 4x squared minus 11x plus 5 is equal to 0. Maybe an option here that you could do is you could try to do the a times c method. So take 4 and 5, multiply them together, get 20. And now start thinking numbers that multiply together give me 20, but actually give me negative 11. And there are none. Okay, so the a times c method does not work in our kind of our hierarchy of factoring. That then makes us do the quadratic formula. So we're going to go the opposite of b, so 11 plus or minus b squared, so 121, minus 4 times a times c of 5, all over 2a, so it would be 8, and it's going to be what x is equal to. So let's see what that discriminant looks like. 121 minus 4 times 5. Discriminant becomes radical 41, so 11 plus or minus radical 41 over 8. I know radical 41 is a prime number, so that is my final answer then for that equation. Or I guess those are my two options. I don't want to say final answer, but those are my two options. We'll do 11 plus root 41. And then divide that by 8. All right, so when I do that, one of these x values is 2.17. Okay. And then the other one is, let's see here, 11 minus root 41. Divided by 8 then is 0.57. Let's go 5. I need to check those to make sure they both work, or if one of them does not work. So remember, we squared both sides. So when we square both sides, we develop the potential for having extraneous solutions. So let's just go ahead and do this. Let's say that if it's going to be, if these are going to work, this left-hand side should equal this right-hand side. I want to plug these x values in. Now these x values are round a little bit, so I'm going to actually do a little bit better rounding when I type them in. So I'm going to go the 2x side. So the 2x side should look like, well, let's just do it this way. I'm going to go x, and I'm going to let it be 2.1753905. That'll probably be good enough. And that's just by calculating that on my calculator. I'm going to store that as x. Hit enter, and that's what it gives me. So now I'm going to figure out what 2x is. So I just type in 2x, and it gives me that quantity back. So now I'm going to type in what the square root of 3x minus 1 plus 2 looks like. And I get that number back, and we're seeing that those two numbers are the same. So what's nice about that is that tells me that is a actual solution. Now I'm going to try the other one. So I go 0.57460,947 should be good enough. Store as x. All right, now I'm going to go see what 2x looks like. 1.149, and I'm going to try this one again. I'll just recall that a little bit easier. Oh, 2x. We want to get to that one. Hit enter, and we see that we got two different values there. So that tells me that this thing was an extraneous solution. Doesn't really work. So 2.17 is the only answer for that question. Moving right along. Margarita is hired by a legal firm at a salary of $4,000 per year. 4 years later, her salary increased to $60,500. Assume her salary increases linearly. Linearly, they tell us right there that we have basically a slope idea here. They're saying at year, they provide you some particular salary, and that's how your ordered pairs are going to look here. So at year 0, I have a $40,000 salary. At year 4, I have a $60,500 dollar salary. Okay, so let's find an equation that relates her yearly salary to the number of years she's worked at the firm. So this is going to be, your idea for finding slope. So slope is going to be difference in your y's. So I'm going to go 40,000 minus 60,500. Okay, so it gives me 20,500. Okay, and now I'm going to go 0. Or sorry, it's negative. I'm going to go 0 minus 4. Gives me negative 4. So divide that out. 20,500 divided by 4 gives me 5125. All right, and negative divided by negative is a positive. So she's getting a salary increase every year of $5,125. Pretty good deal. So they want an equation then. So we're going to go y minus y1 is equal to m times x minus x1. So then my y1 and x1, probably a good idea to use one of these ordered pairs up here. I'm going to use the one that has a 0 and it makes things a lot easier. Y1 would be 40,000 equals slope of 5125 times x minus x1, which was 0. So now I'm going to get y equals 5125x plus 40,000. Get this 40,000. And that tells you then part B here, or sorry, part A, find the equation that relates to the yearly salary to the number of years she worked at the firm. Okay, X being the number of years. It says explain what the slope represents in the context of the problem. She's getting a raise every year of $5,125. Find her salary after 9 years. Well, all I gotta do is take that X value and make it 9. So 5125 times 9 plus 40,000, $86,125. Okay. Hopefully you guys understand that for this problem, that's all great and awesome, but in real life, your salary is not going to be linearly like that. Solve the inequality and write your answer in interval notation. Okay. Remember, when we do absolute value, we first have to isolate the absolute value bars. So I'm going to rewrite this as 18. Move the 3 over. Okay. Now it's less than. So remember what we do with the less than rule. The less than rule says if I have a x plus b is less than or equal to c, then that transforms into, so if that, then you get this statement here, negative c less than or equal to ax plus b less than or equal to positive c. Remember, there were multiple rules that we had to use when we were talking about inequality with absolute value, and even when we had equations with absolute value, there's an equation that we had to deal with, a process we had to deal with. Make sure you understand those, because right here on the practice we're giving you less than, maybe on the real test I give you greater than, so just think about that stuff. But doing this, I go negative 18 less than or equal to 5 minus 3x less than or equal to 18. Subtract 5 from both sides, or sorry, all three parts now. Minus 5, so it gives me negative 23 there, less than or equal to negative 3x, less than or equal to 13. Now you're going to divide by a negative, so dividing by a negative will give me negative 13 over 3. It will give me 23 over 3. Now just think about how this has to work. If we write our inequalities like this, we want the furthest number on the left to be the smallest. Right here, the number on the right is the smallest. But remember what you did, you divided by a negative. So the inequality symbols need to change. So that's what we're looking at. Now we never write an answer that way. We'll write an answer this way. Negative 13 over 3 is less than or equal to x is less than or equal to 23 thirds. But again, they want interval notation, but once I write it in this format, it's simply just transitioning into that notation. Number 8. All right, remember what they want to do here. They were trying to figure out what the graph of this thing looks like, and we got a rule here for when x is less than or equal to 1. Well, first thing I'm going to do, I'm going to figure out when x is 1, what y value do I look at? Okay, so when x is 1, I'm going to put in to here, and I get a y value of 4 back. So I got 1 comma 4. Now I'm going to look for values that are less than 1. Okay, well, less than 1 would be 0. Okay, so plug in 0, I get 3 back. Okay, so 0, 3. I'm going to plug in -1. When I plug in -1, I get 2, so absolute value of -1 plugged in is 2. Plug in -2, I get 1 back. Plug in -3, and I get 0 back. Plug in -4, okay, -4, and I'm going to get 1 back as absolute value. So I wanted to do that. I want to do enough points because I see then that this graph is going to look something like that from the left of 1. Okay, now a couple different ways you could have done it. You could have known what absolute value of x looks like. Okay, it's centered at 0, 0, kind of like that, and it was a terrible picture. Centered at 0 like that, but then when I put 3 on the inside with the x before I take the absolute value, you can use transformation, say that that point there is going to move 3 units to the left. But you need enough points when you graph this to realize that you do get that V-looking shape. The next rule says when x is greater than or equal to 4, so right here where my cursor is, your y value is going to be 3. So I'm going to find a y value of 3. And I'm going to graph that way at a height of 4. That should be on the line 4. Or sorry, the height of 3. That should be on the line of 3 for the y values. For every x value that is bigger than or equal to 4. This point here, because we used less than, and I colored it in, but that should be an open dot right there. So that's piecewise function. All right, so we got these following graphs. As which graphs are functions? So which ones pass the vertical line test? A, B, and C. A, B, and C. Which ones are 1 to 1? Okay, so 1 to 1 means they got to pass the horizontal line test as well. A passes the horizontal line test, and so does B. So A and B are 1 to 1. It says which graphs will have an inverse that is also a function? Well, the ones that are 1 to 1 are the only ones that are going to have an inverse that is 1 to 1 as well. So A and B are the only ones that have inverses. Let's see what the rest of the questions are. It says which graphs has no x-intercepts? They all have x-intercepts, so NA or none. Which graphs has more than one y-intercept? Okay, so we're seeing that graph D has more than one y-intercept. It says find the average rate of change for the function in B on the interval of -4 to 5. Remember, average rate of change is essentially the slope, but we're looking from -4 to 5 on this. So -4 is the x value, so we got -4, comma 0. And if we go to 5, that point is 5, comma -3. Well, average rate of change is the change in y's, so 0 minus -3, change in y, so delta y, over delta x. Well, the change in my x's ends up being -4 minus 5, okay, which ends up then being, 3 over -9, so it becomes -1/3 as your average rate of change. And make sure that makes sense to you. We're decreasing here, going from there to, because we just found basically the slope of that secant line right there. Okay, and that slope is down, it's going down, it's decreasing, so that should verify that your slope is -1/3. Going on to the next one. This is find f of -1. Okay, so I'm going to find -1, go up to my graph. Remember, f of -1 is actually asking you for the y value when x is -1, so that's going to be 7. It says solve for f of x is equal to 2. They want to know when you know that the y value is 2, what is the x value? Okay, so here it looks like it's, and I say it's approximation, -2.5. Okay, so let's find the domain and range of f. Well, this thing is going on forever, so the domain is going to be x values from -infinity. But if I come up here, my x values stop at 2. I don't have any other points beyond 2, so I'll stop at 2. So that's my domain. My range, again, start putting like a horizontal line in here and pushing it upward. So the first y value you would encounter would be -infinity, but the last y value you would encounter up here is positive 8. And we'll include 8, so it should be a bracket. Says estimate any local maximums or minimums. Write your answers as ordered pairs. Label the points as a max or min. This here would be, so 0, 8 is a maximum. Okay. Right here, this point of 2, 4 is a minimum. And this one's a local minimum because it's smaller than all the other y values that are around it. This one here is actually, it's a local maximum because it is greater than any y value that's around it, but it is also global, meaning that for the entire graph, that's the largest y value that you get. We don't have any global minimums because it goes to negative infinity. So those are your two max and mins for that function. The next part asks on which intervals is this graph increasing or decreasing. So increasing from left to right. Okay, my graph is getting bigger from negative infinity up to 0. Okay, remember increasing and decreasing, you're being asked for your answer is going to be x values. So you're answering what x values are my y values getting bigger. So we look at increasing being defined by the y values, but you write down the x values that it's doing it for. Okay, so your answer is always x values for what y values are providing that relationship. So it's increasing between negative infinity to 0, but it's decreasing from 0 to 2. Okay, 0 to 2, your y values are getting smaller. Okay, so remember these were the x values that your y values were getting successively smaller. On a test, I don't care if you put brackets, square brackets, or parentheses. The logic is we should probably use parentheses, though, because at that point, at 0, 8, we're in the transition from increasing to decreasing, so we're not doing either of those things. But if you put brackets, I won't count that wrong. Describe how the graph of the function negative 5 times f of x plus 4 minus 2 is a transformation of the graph y equals f of x. So this y equals f of x is just kind of a parent function. Could be x squared, could be x cubed, could be whatever. But we know that the 5 out in front is going to be a vertical stretch. Okay, the negative out in front is an x-axis reflection. The plus 4 on the x is going to move left 4 units, and then the minus 2 is going to move down 2 units. So let's find f minus g, so I'm going to go 5 plus x squared minus root x minus 3. Okay, and it also wants us then to find f divided by g, so f divided by g would be 5 plus x squared all over g, which is root of x minus 3. Okay, you can leave it that way, that's fine. If they ask you for the domain, remember the domain, this one here is all real numbers, and this one here, x minus 3, has to be greater than or equal to 0, so x got to be greater than or equal to 3. The domain of these things is, and I'll put 0 here, put 3 there. We know that the domain, see, eraser is terrible. The domain for f is going to be all real numbers. The domain for g is now things bigger than or equal to 3. So the domain of their quotient, or the domain of their difference or sum or whatever I ask you, is the intersection. So the domain here is 3 to infinity. They ask you for f composite g. Okay, f composite g looks like this, f of g of x. So I'll rewrite that as f of root x minus 3. And then that's going to be changed to then 5 plus root x minus 3 quantity squared. You can simplify, you get 5 plus x minus 3, so you get x plus 2 as your final composition. But it's domain. Remember, domains are different here. You first have to look at the domain of the input, and that meant that x had to be greater than or equal to 3. And then you need to couple that with the domain restrictions that occur in the final composition. There is no domain restrictions there. So the only domain restrictions we have here is 3 to infinity. Again, if you graph those, kind of do that real quick here. We had, what were the two functions? 5 plus f of x is equal to 5 plus x squared, and g of x is equal to x, our square root of x minus 3. If we compose those are two functions, compose them, we should get a line, but that line should only exist from an x value of 3 to infinity, and that's what it does. Moving on, getting close to the end here. They want f composed of f of 4. I would not create a rule here. I would just go to f of 4. Okay, and so basically they're asking this. Evaluate f of 4. So I plug 4 in, so I get 16. Plus 5 is 21. So then I'm asking the question, what is f of 21? Go plug 21 in. 21 squared, I think it's 4. Is it 441? 21 times 21. Yeah, 441. And then add 5 to that, so I get 446. And that then is f composed of f of 4. And I believe the next one is the last one. It says, use the graph to sketch the inverse of f inverse. This point here is 3, 4. Get some other key points here. I got, 2, 6. Looking maybe here, we've got -1, 8. This one here is -6, 10. So I'm not going to graph this for you, but what you would want to do is realize the relationship that if I'm going to have the inverse is going to have a point of 4, 3. We just flip them. It's going to have a point 6, 2. It's going to have a point 8, -1, and it's going to have a point 10, -6. Okay, and if we flip those like we did here, plot those over here somewhere, and you're going to then eventually develop that inverse graph.